Oh my gosh, there's some feedback. Can you guys hear some noise in the background? Here. Is this better? Is this better or worse? Is this better or worse? Better? Okay. All right, there we go. It's crazy when you have like three mics. All right, so we wasted some time. We wasted some time trying to get my mic set up. Sorry about that, guys. Windows updated and everything crashed, so I'm still getting everything raring and going. So now that we're good to go, let's get into this. Happy Friday. Good morning. I hope you guys are doing okay. I hope that you're not inhaling too much smoke. That stuff is nasty. It's been giving me headaches. So let's get going. I just wanted to check in with how you doing on your homework. Remember that your grade is based off your correctness on your homework. So I would say I have less than 1% of my pre-calc students asking for help for me personally. So make sure you guys, if you have questions, that you're doing that, okay? And remember, this is all review so far, so hopefully it's going okay. And again, I want you guys, remember when we're doing online, we have to change things up a little bit, and that means you have to reach out and ask questions a lot more, okay? And here's my email if you haven't done that. So we're going to do 2 more review things today. One of the parts is pretty confusing, so I'm going to do my best to make it understand. Now remember, I have lots of ways of explaining, so if I explain it in a way that doesn't make sense to you, make sure that you let me know and I can explain it in a different way, okay? So first off, what we're going to be doing, 1.6 in the book is all about family functions. And so for family functions, what you really need to know for family functions, and this is going to be so important, the further you go in math, the less time you want to spend on like what's a quadratic, right? And so it's just one of those it's one of those necessary evils of math, is that sometimes you just have to have things memorized, which sucks because with math it's so logical that you should be able just to work it out. But there are a few things that are worth committing to memory, and that is the parent functions. Okay, now the parent functions are just a family function with no transformations. Okay, and I'm so glad that we said no transformations, because this is what 1.7 is, and this is why we move them together. So when I say you need to know your family functions, what I'm really saying is you need to know your parent functions, and that means it's the function with no transformations, because if you know the parent function, you're going to be able to look at any function that has transformations and be like, well, I know these things are happening, so I got to look out for them, okay? So to do this, I'm going to switch my screens really quick. Ooh, I'm going to transition. It's going to fade in and out. This is so cool. Okay, that really wasn't much of a fade. I'm going to have to work on that. I feel like my transition game is weak. So with this said, I'm looking at our Precalculus 4th period Google Classroom. Make sure up here on classwork, that's where everything is going to be. I also put up a note about your last homework. Hopefully you guys saw that. I didn't realize that WebAssign uses set notation. I'm really sorry about that. I'm new to WebAssign. I should have reminded you that U, which means union, is basically their use of a comma. It's not really, but for us, that's all we need to know. So you need to you can't type in a capital U. I tried it, doesn't work. So you have to go to the sets notation, and you have to do that for you. You should have had your homework done already, and no one sent me an email, so I'm a little confused why no one asked for that. I'm just going to assume that's because you read the Google class post. Okay, so if we go to classwork, this is something that you're going to need to access. So I'm in classwork resources. I put up a new one. It's called Review of Parent Functions, and then graphs of parent functions, okay? So you guys are gonna have to use this because, like I said, unfortunately, some things we're gonna have to memorize, and this is one of those things where we're gonna have to memorize, okay? So I'm gonna go over this pretty quickly. Can you guys see this okay? you guys are super engaged right now. um, super lame, that's fun. Oop, that's not what I wanted to do. Just a second. A bit zoomed out. Yeah. I'm working on it. Okay. And then I want to add a new layer. You don't want it that big. This big. All right, okay. So I'm going to zoom in a little bit. There, is that better? I can't, I'm trying to, does it, the whole screen fit on yours? I wish this was better. There we go. Okay, that's what I got. That's what's going to work. Okay, so and just really quickly here, this is too big. Okay. All right, so hey guys, let's just talk about this. So just as an expectation, I'm going to expect that you guys know these. So which ones do we need to know? So we need to know, oh my gosh, that's way too big. We need to know linear functions. Okay, so just to highlight a couple of things. So they put slope-intercept form, but remember there is also the other one. There is point slope form. So y minus y1 equals m. Ooh, that's an m. X minus x1. Okay, so you guys need to know this as well. So make sure you guys know how to do that. Okay, I'm a little sad that it's not up there. It makes me a little sad. Okay, and then what else do we have? You need to know the domains for these functions. So as you go underneath linear function, you'll notice that there's no domain restrictions. So right here, you'll notice that there's no domain restrictions. So super important to know that. Also super important to know that there's no range restrictions. When it says m can't equal 0, what that's referring to is if you have a horizontal line, right, the range doesn't change, does it? Okay, so if you have a horizontal line, the range is only going to be, so if I have a graph here, and this is 4, right, then the range would always be 4. Okay, so just something to look out for there. Okay, now on this one, the next couple of things I want to point out, for the x-intercept, all they did was they took this equation up here, and they solved for, they set f of x equal to 0 and solved for x. So they subtracted b and then divided by m. The y-intercept, we define b as being the y-intercept, increasing when the slope is positive, right? So you can see here the slope is positive, so it's always increasing, and decreasing when the slope is negative. Okay, so it seems really basic, but you need to have that down pat, or else, because you might think you know it, and then you get to a really complex problem and your brain freezes up, okay? Absolute value, you need to know it. Okay, we're going to talk about graphing absolute value here today, so we'll talk about that in a little bit. But remember, and in calculus, this is the definition that you're going to be using. Absolute value is a piecewise, and that's what's really important. So everything works for it. Notice how they use the bracket here for 0. It's the lowest it can be, and there's a dot there. Remember a really annoying thing that your book does? You guys see how there's no arrows here at the end? There's no arrows at the end of any of these functions. So they chose not to do arrows. So if a function doesn't continue forever, you can see down here in the greatest integer function, they put a dot, okay? So if there's not a dot at the end, you can assume that it goes on forever. So that's a really important thing you need to know. This book's, if it doesn't put a dot, it's assuming it goes on forever, or if it doesn't say it explicitly. Notice now, this one just says intercept. That's because it's their way of saying the x and the y are the same. So you'll notice that's same for the square root here. Okay, so if it just says intercept, that means it's just the same. And then increasing, decreasing, even function, even and y-axis symmetry are the same thing. Square root, same thing. You need to know these. So some things that you need to be aware of, I'm going to get going here in a second. You do not need to know the greatest integer function. Okay, but you do need to know everything else on this front page, okay? So does that make sense? So you need to know everything but the greatest integer function, and then you do need to know the rational or reciprocal function. I'm never going to call it the reciprocal function. I'm always going to call it the rational function. You need to know exponential, and you should know logarithmic, though we are going to do logs a little bit later, okay? So we are also going to do sine, cosine, and tangent later. We're going to do cosecant, secant, and cotangent. Those are the reciprocals, and then the inverses as well. But for right now, all you need to know is linear, absolute, square root, quadratic, cubic, rational, exponential, and you really should know logs, okay? All right, so now that we have that, so I'm just, and it's just unfortunate, but I'm just going to say, hey, you just need to know them. You need to memorize that. You need to know it. You need to have it accessed at all times, okay? So next up, what I want to talk about is how to graph piecewise functions. Because in real life, it's rare to have one equation perfectly fit everything. It's usually a combination of equations. So what I'm going to do is I'm going to go ahead and I'm going to show you how to sketch a seemingly complicated question. Now, I really like this question that I am writing down because it has three different what's it called? Family functions. Sorry, I should be Vanna Whiting this, shouldn't I? All right, so we have f of x is the piecewise function, 3 square root of the quantity of x plus 10 when x is less than -1. We have 2 times the absolute value minus 5 when x is greater than or equal to -1 but less than 1. And then we also are going to have 4 minus the quantity of x minus 2 squared when x is greater than or equal to 1. Okay. So you might be like, oh my gosh, correct, how are you going to do this? Really easy, guys. We totally got this. Okay. So the first thing I'm going to do is I'm going to make a Cartesian plane. And remember that if you are at a party this weekend and you're drinking tea, make sure your pinky is out. Okay, and you go, oh yes, what did I do in math class? Oh, I drew some Cartesian planes. And of course you're drinking tea because tea is healthy and you should make smart decisions. Okay, so here we go. That was really just an excuse for me to drink tea, so thanks guys for having fun. Just made your day, which is good because really anything I do should make your day because it's the first thing you're doing, right? So my job is really easy there. So so the first thing we should look at, guys, these right here. That's an eye, by the way. You like that? Here, I can put some beautiful eyelashes on. Now it just looks creepy. Now it looks like a biology thing. It looks like, what are those called? Whatever. I can't think of it, a singular cellular thing. Anyways. All right, so we really just want to look at these. It looks like everything's happening around -1 and 1. So let's start with this first one. It's happening at -1. Oh, it's going down, right? It's happening. Okay, so what I'm going to do is just, now, first thing I want to notice, it doesn't equal, right? So am I going to be using an open or a closed circle here, right? So right here, am I going to be using an open or a closed circle? Don't answer all at once because you're overwhelming me. So is it open or closed? Yeah, it's going to be open, right? So let's just plug this in and get this point. So I have -1 plus 10. That's 9, okay? Square root of 9 is 3. 3 times 3 is 9. So I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9. And don't get mad at me that my graph isn't square. No one cares. Or maybe you care. All right, so it's going to be open, right? So this is -1, 9. Okay? And then, so that's the first part. That's the easy part. You should always be able to get these points, right? That's just standard. Then, this is where parent functions are going to come in. I know that the parent function, square root of x, starts at 0. So there's a transformation here, and we're going to talk about that transformation in just a little bit. But remember, if it's inside, right, it's going to be backwards. So plus 10 really means minus 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I know that it will equal this because it says anything less than -1. So I know my square root's going to go here. And what's really cool, if I'm just sketching, then I know that it starts steep and then it goes like that. I always call this the claw. All right, anyways, looks kind of like a claw. All right, so there you go. And you sketched it. So there's your square root, right? And it is going up a bit faster because it has a vertical dilation. We'll talk about that in a little bit, okay? So next equation, I want to talk about, so this one has 2 important points, so -1 and 1. So at -1, we check here. So is it an open or closed circle for the second equation? Open or closed at -1? You guys type that in. So it's either open or closed. What I do is I just wait for the first person to respond, then I copy paste their answer. Okay, so that was a joke, don't cheat. All right, so let's plug in -1. So 2 times absolute value of -1 is just 2. 2 minus 5 is -3. Okay. And then I'm going to have a closed circle. Okay. In calculus, we talk about what type of discontinuity this is. It's a jump discontinuity, because if I was here to get down here, I'd have to jump, and then I'd get down there. Okay. Then we have to know for the parent function here, it's an absolute value function, so it has a vertex, right? And the vertex is normally at 0, 0. So then we have to take a look at the transformations to see how we get there. And this one, it's outside the function, so it's output. So I'm just going to go down 5. So 1, 2, 3, 4, 5, and I know that I'm going to have a point here, and then, right, back to elementary school, just connect the dots, okay? Then another thing I need to know about absolute value is that there's y-axis symmetry, right? So on the other side, if I'm going to 1, right, and how do I know 1? Because I know I'm going here. Now I have to be careful here. Is this an open or a closed circle? Ooh, look at all this interaction today. It's like tippy tip tap with your fingers. Okay, so is this open or closed here? It is open. Okay, so I'm going to go, and I know since there's symmetry, right, I don't need to plug it in. And I can go like this. And if you're doing this by hand, you should do it much bigger, right? Because in AP Calc, I always tell my students, the big as you get, right? Because almost comically big, because you want people to know what you're trying to communicate. All right, so we're done with that one. Next one is this last one. So it's a quadratic. So let's take a look at what's going on with this quadratic. Remember, a quadratic can either be happy or sad. So looking at this one, looks like this one is a sad. It's negative, right? So we're going to, so if I look on the inside, everything is backwards. So it's going to be, instead of left 2, it's going to be right 2. And then it looks like it's going to be up 4. So to do this, the first thing we can do is just plug in a 1. So if I plug in a 1, I get 1 minus 2 is -1. -1 squared is just 1. Times that is minus 1. So it's 4 minus 1, which is 3. And I'm just going to go ahead and say this is closed. So I'm going to go at 1. I'm going to go up 1, 2, 3. Okay. And then that's my closed circle. Okay. All right, so next I want to find my vertex, right? So this isn't my vertex, right? My vertex is usually at 0, 0, so it's moved. So to find my vertex, I'm going to say, hey, I'm going to go right 2, and I'm going to go up 4. Okay, so I know it goes like that. And then if I had time, I would find the 0, right? So that's when the y is 0, so I'd go 0 equals 4 minus x minus 2 squared. Oh crap, now I'm just going to get to it. I'm just going to go super fast. All right, cool. So I'm going to go 1, 2, 3, 4. So I know it's going to be here, and I know it's going to go. And I'm better than the book, so I put arrows because I'm better than the book. Okay? So that is a quick review. So again, notice how I used these important points, right, to get my basics, but you have to know your parent functions. If you don't know your parent functions, you're going to have a bad time, okay? So just really important, because after I'd gotten this, I might want to write out the domain and range, right? So my range would be 9, right? But I'd have to do a parenthesis because it can't equal 9. And then it'd be a negative infinity to 9, but it can't include infinity or 9. The domain would be negative 10 to infinity. Okay, but a bracket around negative 10. I should have written that down. Because we should always be practicing that. Okay. All right, cool. So if you guys don't have any questions, I just wanted to show you that, so we can move on. So transformations, I want to spend most of my time on. Ooh, time's flying. Spend a lot of time on that. Okay, so 1.7 are transformations. And you have to be careful because transformations have more than meets the eye. Okay, any Transformer fans out there? All right, okay, whatever. That was my Transformers joke. All right, so transformations. I'm just going to go through them. So let's remember, right? So I'll go through each one. So just inside the function. Okay, so inside means input. Right? So if you're inside the function, you have input. We need to remember that this is the x-axis, okay? And it is always backwards. Now, I say backwards, but that's street language, right? Okay, so when I say backwards, what I mean is inverse operation. And hopefully in Algebra 2, you learned why it's backwards, right? Because that's how you get back to 0, right? You're moving away from 0. Okay, so that's what's going on here. The domain for the last one was a bracket negative 10, comma, infinity. Okay, so bracket negative 10, comma, infinity. Okay, so hopefully you guys learned that in Algebra 2, right? So it's backwards because you work backwards to get to 0. Okay? All right, so let's do a couple of examples of this. Okay, so the parent function here is 2 is the squared. So remember, parentheses really help out. So if you take a look here, this is inside, right? This is inside, okay? So this would mean that I'm going to go the inverse operation. So what's the inverse operation for minus? It's positive, so I'm going to go right 2. Another example, I might have x plus 3, right? Again, I'm inside the absolute value. The inverse operation of positive is minus, so I'm going to go left 3. And again, it's shifted left 3 because I have to put in a negative 3 here to get to 0. It's shifted right 2 because I have to put in a positive 2 to get to 0, and that's why it's backwards. You're getting back to 0, getting back to the roots, getting back to the fam, you know? Getting back to the fam. All right, so outside of the function. Okay, so just remember it has the word out in it, right? So that means it's output, right? It's kind of neat how that works, right? Outside output. Okay, don't want to be outside right now, a little smoky. Okay, so this is the y-axis. Okay, and it is always normal. whatever normal means, right? So let's do a couple of examples of this. Now remember, we don't normally draw parentheses here, right? So we don't normally draw parentheses, but just remember there's parentheses there, right? So this plus 2 is outside of the function. So if it's outside of the function, we just behave like normal. So a plus 2 just means we're going up 2, right? Because up and down is my output. Also, let's say I have absolute value of x minus 3, that would be down 3. Okay, so if it's outside of the function, it's normal. You don't have to worry about it. The inside of the function is where everyone loses their minds. But remember, we're getting back to 0, right? We want to get back to 0. All right. Just cruising here now, huh? Okay, so let's get to the stuff that people hate, where people get confused. People get confused with dilations. Right? So dilations make things bigger or smaller. So if your scale factor is greater than 0, you get bigger. When your scale factor is less than 0, you get smaller. I don't have time to talk about when the scale factor is 1 because I could spend a whole class talking about when the scale factor is 1. If you've ever been in architectural design or engineering, actually copying something is really difficult. If you work in a factory and you want to make the same product without defects, you might have ever gotten a effective product. It's really hard to make the same thing, but we can talk about that later. Okay, so let's talk about vertical. So vertical dilations are the easiest dilations because we don't have to worry about the whole backwards thing. Okay, so it's the output. So everything is normal. Okay, so we're going to do 2 examples of this. Again, this isn't the one that people have to worry about. So if I have 2 times square root x, now remember, this is the same thing as this, right? So people get confused here. So remember the parentheses, right? So this squared is only with the x, right? So this 2 is on the outside, right? And this one, it's really obvious that the 2 is on the outside, but the squared, if there's no parentheses, just goes with the letter next to it, okay? So this is we call this a vertical stretch. Oops. Okay, of 2, okay? And what does that mean? It means all outputs are multiplied by 2. So remember, with the vertical dilation, it's really easy because it happens after the function. So if you think of PEMDAS, parentheses, exponents happen first, right? So parentheses. So every function has parentheses around it. We just don't write it. So you always do the function first. So you're just taking the output and multiplying by 2. This is why vertical dilations are so easy, because it happens after the function. Okay, another example, okay, would be if I have 1/4 the absolute value of x. Again, it's on the outside. So this is a vertical shrink. Right, so that just means all outputs divided by 4, or I mean divide, when I say divide by 4, right, multiplied by 1/4, okay? All right, cool. Sorry, I wasn't in focus there. I think that looks a little bit better now, okay? So again, vertical dilations, usually not the problem. If you do have problems on it, you're a freak. No, I'm just joking. You should ask for help so we can get through it, okay? All right, the ones that really tend to, I was just joking about the freak comment. That wasn't a funny joke. Guys, I never judge you if you have a question, ever. I just love you guys, and I want you guys to do well. I would never make fun of you at all, ever, in front of you or behind your back. I want you guys to get math. Please ask questions, okay? Or is on. Oh, sorry, I just immediately when I said that, like, I love you guys. I want you guys to do well. I want you to be well. I don't want you guys to be in a bad place. Horizontal dilations. Okay, so these ones give students headaches. So I'm going to do my best to explain this algebraically and explain this visually so that you guys can get it, okay? So this is an input thing, right? So if it's an input, everything is backwards. And students really struggle with this, but remember backwards means inverse operations, right? And if you forgot what the word inverse is a fancy word for opposite, okay? So I'm going to do an example. Example for you. No, you example for. No, I don't know. I'm not Yoda. All right. I'm cooler than Yoda. All right. So I'm going to start with something, and we're going to go on a journey. And if you get lost in this journey, you should let me know. Okay. So as you can see, this too is in the input. Okay. So it gets confusing here, especially with this, because with all the parent functions we're doing now, horizontal dilations aren't actually a thing. Okay, that's why it's confusing. Because it turns out that horizontal dilations can be converted to a vertical dilation. Now, this isn't true when we get to trigonometry. A horizontal dilation, it has a very distinct meaning, and it has nothing to do with the vertical dilation. So I think people get confused here because they're like, why would I ever do horizontal dilations when I can just do all vertical, okay? So I think that's where people get really confused. So I'm going to do this, and then we'll address that later, okay? So if I draw this is the square root, this is x squared, okay? Now, what's happening here, and this is where people get confused, is that people look at this and they struggle with what it's being dilated with. But now remember, input, everything is backwards. So what's the inverse operation of multiply? It's divide. So if I wanted to get back to 0, to get rid of the 2, I'd have to divide by 2. Which isn't technically true. That would get me to 1. I regress. Okay. But, because we're talking about output. That was dumb, right? So if I'm trying to get back to the same output, I have to divide by 2. So this is what's happening. So we say this is a dilation, or dilated, by a factor of 1/2, okay? Because you see the 2, but we have to do the inverse option. It's actually 1/2, and then it's 1/2 horizontally. Okay, so now what does that mean? Well, the graph of this is going to look freaky familiar to a vertical dilation. Okay, and this is what it means visually. So take a look at the distance from here to here. Let's call that A. Okay, and let's say that is f of A. Okay, to get the same output. Okay, to get the same output like this. Okay, the same output, that distance is going to be 1/2 A. So this output right here is f of 1/2 A compared to the A. So really, if you think about it as an accordion, you guys see what I'm saying? You're squishing it together by a factor of 1/2. You're making it 1/2 tighter rather than blowing it up 1 by 2, right? So blowing it up by 2 would be moving it A. You'd be going 2 times A, so you'd be way over here, okay? So I'm trying to help. I hope that visual helps, right? So if what this is saying is that if I had my original function, right, and this green function is 2x quantity squared, okay? So what's going on is that if this normally was f of A, the same value is now going to be f of 1/2 of A. Okay? So I hope that helps. So the horizontal is squishing it. Okay? No one is asking questions, so this means that I'm striking gold with this one. All right, so now what's confusing here is we actually, now all this is done. Okay. Now what's confusing here is we could actually just say, hey, instead of writing this as a horizontal, and this only works for quadratics, absolute values, and cubics, and polynomials, okay? So when you get to trig, this doesn't work, okay? So this only works now. But you're like, hey, I don't want to deal with the horizontal thing. So you can just be like, well, what's 2 squared? Right? These are equivalent. So when we say dilated by a factor of 1/2 horizontally, it's the same thing as vertically dilated by a scale factor of 4. So this graph right here is also just 4x squared. And that's what gets people confused, is because we don't do trig, and we should be doing trig so that you understand that a horizontal dilation is something different. Because in trig, a horizontal dilation has to do with how fast the humps happen. Okay? Whereas the vertical dilation is how tall are the humps. Okay? Did that help out, guys? No one's saying anything. Okay? Makes me, thank you. Because like maybe my mic's not working and you guys are just like, whatever. Thank you, I appreciate that, Graham. Okay. Now, the next thing that makes these hard, yes, there's 2 things that makes this hard, is that with horizontal dilations, they mess up horizontal translations, okay? So what we're going to look at is an example here, an expression. Okay, so horizontal dilations ran out of room. Horizontal dilations mess up horizontal translations. Okay? Horizontal dilations mess up horizontal translations. Okay? So this only happens with horizontal dilations, but it's super important because when we get to trig, again, going to be super important. Oh, and fake wood is so nice. So nice. Okay, so looking at here, so when does it affect? So when the leading coefficient is not 1. Okay, so when the leading coefficient is not 1. So that's right here. Okay, do you see how the leading coefficient is -1? So then you must factor. Okay, so we need to factor. So to do this, what I'm going to do is I have to factor out this negative. So I'm going to have like this. So I factor out that negative. So I'm going to have x, positive x, and positive 2. And it's important that we did that because now we notice, right, we're going to be going left 2, and, ooh, spoiler, when it's a negative, it's not a dilation, it's a reflection. So it's actually reflected, and we'll talk about that next, reflected over the y-axis. Okay, so horizontal dilations are mean, right? They are confusing of what they mean, and they, if your coefficient is not 1, you have to factor it out. Okay. Oh my gosh, I got 10 minutes. All right, so next up, how am I, where am I? Okay, so the next thing I want to talk about, taco, is reflections, because I just brought it up, right? Oh my gosh, come on, figure it out. Reflections. Okay, so there's 2 reflections you need to know. Over the rainbow, no, I'm just joking, over the y-axis. Okay, so just remember that's just a negative with the input. Okay, this is also called never mind, I'm not going to say that. Okay, and then there is over the x-axis, okay, which is a negative on the outside. I'm going to draw a picture of these really quickly because, you know, who doesn't like pictures? So pictures really quickly. So if I have cubic, okay, and then I want to draw negative x cubed, right? So that is a reflection over the y-axis. Okay, that's a really cool looking symbol. And then the next one, I have x squared, and then I have negative x squared. Okay, so those are examples of that. And then with the very limited time, I'm going to try to do two things. Oh my gosh, I'm going to try to do two things really quickly. Time just flies when we're having fun. So the first thing I want to talk about is multiple transformations. Okay, so if I have a function g of x equals 2 square root of negative x plus 3, sometimes I put a little mark there to know it's the end, and then plus 1, okay? So just remember, I like to start with the outsides because outside the functions are easy. So I might say I have a vertical dilation of 2, okay, because it's on the outside. I also love this joke for all my Spanish speakers. Vertical dilation of 2, and then I'm also going to have a vertical translation up 1. Make that 2 into a 1. Okay, and then the inside is more difficult because if you were just to start going, can't because this isn't 1, so I have to factor that out. So if I were to factor that out, I would get this. I get 2, and then I'd have negative x minus 3 plus 1. So again, right here, I can see that I have a horizontal translation right 3, and I have a reflection over the y-axis because it's a multiply by a negative on the inside. All right, whew, I'm doing okay for time. I got 5 minutes. Boop, 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 boop. Okay, so the last thing I want to do is have to eat my hands. But the last thing we're going to do today a Vsauce? Okay, if I Google Vsauce, is that going to be school appropriate? All right, so here, just a second. Dude, I'm a really interesting YouTube channel. Okay, so like and subscribe. Okay, so Vsauce. All right, so I'm going to sketch a graph really quick. Okay, and then I'm going to plot some points. Okay, really quickly, I want you guys to write an equation for this. Wow, you guys are getting mad at me about Vsauce. I'm going to have to check out Vsauce. Is he on Twitch or YouTube? I mean, I'm also on YouTube, so I'm also on Twitch, and I'm also on, no, just Twitch. Twitch and YouTube. So hopefully you guys are taking a second and trying this out. So quiet. So quiet out here in the wilderness. It's just so nice. Oh, look, a deer. Oh, hey, so let's go over this. Let me give you some strategies. So the first thing you want to look at and be like, say, hey, what's the family function? So hopefully you noticed that the family function is, or the parent function, right? So the parent function is x squared, okay? So all we need to do is figure out the transformations. So remember, x squared is all about the vertex. So it looks like it shifted left 3, up 4. So I might go like this, and I might start with, oop, I shouldn't do that because we don't know if it's horizontally shifted yet. But hey, I'm just going to go like this. If you're writing the equation, don't do horizontal shifts unless you have to. Just make it a vertical shift, okay? It's just so much easier. Did you guys hear that? That's like my pro tip of the day. If you have to do something that's not trig function, that's like hard mode, right? You don't have to do a horizontal dilation. Just make it a vertical dilation if there is one, okay? So first off, it looks like I'm going to the left 3, so it's inside, so I'm going to go backwards, and then it's up 4, so it's outside, so it's going to be normal, okay? But let's double check. Now, so this is the skill here, is if you're starting to get your equation, you should always just plug in some points. So for example, if I plug in -1, do I get 2? So -1 plus 3 is 2. 2 squared is 4. 4 plus 4 is 8. So there's a dilation going on here, right? So let's just think. So I got 8, but instead the answer is 2. So how would I get from 8 to 2? I would go, did I do that right? No. Anyways, right here I would write 1/4. No. Yes. That -1, 3, 2 is 4, half of 4. No. What am I going here? Guys, you're killing me. Okay, so to get the 4, so this is 2. So what plus 4, I'd have to have, oh, -2. So then I want this to get to 2. So I would go 1/2, and then I'd make this negative. Oh my gosh, that took way too much time on my part. So let's try this out now. So I'm saying this is mine. So if I go -1/2, and it's negative, right? Because it's sad, right? It's sad. So I'm going to have -1 plus 3 squared plus 4 equals y. And then -1 plus 3 is 2. 2 squared is 4. Half of 4 is 2. -2 plus 4 is 2. So we're good to go. This is my equation. All right. It is 9:50. So I'm going to go ahead and say that this lesson